Okay, so now question 6 says the residents of Mahjong were asked to classify their local bus service. 25% of the residents classified the service as good, 60% classified as satisfactory, and 15% of the residents classified it as poor. A random sample of 110 residents is chosen. So use suitable approximation. So which approximation we have? Binomial. We have learned binomial to normal approximation to find the probability that fewer than 22 residents classified their bus service as good. So what are we supposed to find here? What is given to us is what is actually the success according to the part A. When they have chosen the random sample of 110 residents, that means n is going to be 110. Then we need to find the probability that fewer than 22 residents classified their service as good. So when they are mentioning their bus service as good, they are only talking about that the success in this particular case is your service is good. Okay, this is success to according to like for this part of the question. So if you write the probability of the success, so we always write it in the not in the percentage form but in the decimal form. So 25% means 0.25. Also write for the rest of them 0.6 is will be used for the next coming parts maybe, and 0.15. so here we are just going to use 0.25. if success is 0.25, so we are not concerned with the rest of the satisfactory and poor, we are just concerned with the failure then. So the rest of it will be failure. So 0.75 is going to be failure according to this part of the question. Okay, and we already found to be 110. Now we know some of the formulas to use for binomial to normal approximation, and that are mu, the mean is equals to np, and standard deviation is equals to root npq. Okay, and also we have to do some of the corrections which we will be doing also. So first look into what we have to find. We have to find the probability that fewer than 22. So we need to find the probability for x is less than 22. Okay, for this reason we need also we need to correct this x value as well. How do we do the correction? We look for this 22. Okay, now if this is 23 and this is 24, so we have probability for x is less than 22. So less for binomial to normal approximation, we take into consideration the decimals. So this is 22.5, this is, sorry, how I'm doing it, this is 21. So this is 21.5. So we need the left side of 22 because less than 22, but less than 22 means that 22 should not be included. So we should be starting from this point 21.5 and going to the left side. So it will be your x should be less than 21.5. okay, this is how we do the correction for the binomial to normal approximation. Now just look into the working. So we need to find the probability of x is less than 21.5. And what will be your mu for it? Mu will be np, and n is 110 times 0.25, so that will be 27.5. The standard deviation is root npq, that means 110 times p is 0.25 times 0.75. So this will give you 4.5414 is your standard deviation. And next, as always we need to find the z value, and that is x minus mu over standard deviation. So what is your x value? 21.5 minus 27.5 over 4.5414. So that will give you minus 1.321. Okay, z value will always take up to 3 decimal places. Okay, so yeah, so that means we need to find the probability that for x is less than minus 1.321. so what we need to do for this, like first of all, whenever we need to find the table value for this, what do? We make a bell shaped diagram and we identify the points. So obviously a negative point will be somewhere here, minus 1.321. This is your z value. X is less than this, so yeah, most probably this. And which area do we need? We need this area. So if we will be finding the table value, we cannot find for the negative one, so we need to flip it. We will be flipping it. So when we will be flipping it, this becomes your area, but we are not supposed to find this. Okay, when we will find the table value for 1.321, we will get the table value for this region. So 1.321, let's find that out. We had the z value table above, so let's take that. Or let's look into the same table, 1.321. So 1.3 coinciding with 2 is this 9066. So this is your 1.32, and where is your 1? This is your 1 coinciding here. So that means we need to add 2 in this, 0.9066. So we will be having your phi value of 1.321 is 0.9066 plus 0.0002. So this will give you 0.9068. Okay, so but we need the area of this region. So for this region, for probability of z less than minus 1.321, it will be equals to 1 minus the phi value of your 1.321. So it will give you 1 minus 0.9068, and this will give you 0.0932. Okay, and that's it. We have to first change the binomial to normal as your n was very large, and then you find the table value, and then you find the actual z, like the probability for the given z value. So it comes out to be 0.0932. Now let's move on to the part B. Part B says, for a random sample of 10 residents of Mahjong, find the probability that fewer than 8 classified their birth surface as good or satisfactory. So if we are now going to talk about okay, now you have 10 residents as sample, means out of 10, fewer than 8 classified their birth service as good or satisfactory, means good or satisfactory is your success here, and your success is happening how many times? 8 out of 10 times. So clearly it's a binomial distribution question. Okay, so what we will be doing, first define the success is either good or satisfactory. So what is the sum of good and satisfactory? 0.25 plus 0.6. So this will give you 0.85 is your success. So obviously your failure would be then 0.15. Okay, now what are we supposed to, okay, yeah, also n is 10. Okay, and what does this mean? The probability fewer than 8. So that means we need to find probability of x is less than 8. Okay, in case of a binomial distribution, what do? Either we have to find the probability at x equals to 0, because less than 8 means from starting from probability at x equals to 0, 1 2 3 4 till probability at x is equals to 7, because less than 8 is 7. Or you can do that probability x equals to 8, x equals to 9, x equals to 10. So you can subtract these three from 1 to get the probability. So it is better if to do the find the probabilities for 3 of them rather than doing it for 7 times. So how we are going to do this, we will be doing probability of x is less than 8 will be equals to 1 minus probability of x equals to 8 plus probability of x equals 9 plus probability of x equals 10. Okay, so what is the formula for the binomial distribution? Let's write that also. That is NCR Q n minus r and p to the power r. This is your formula. for binomial distribution. So let's use it here. So it will give you 1 minus probability at x equals to 8 will mean 10C8 failure n minus r, failure is 0.15, n minus r means 10 minus 8, and success to the power r plus 10C9 failure to the power n minus r and success to the power r. Zero point 85 to the power 9. Okay, and the one last term 10C10 failure to the power 1 n minus r, that means 10 minus 10, and success to the power r, that is 0.85 to the power 10. Okay, subtract this all from 1. Directly do this in your calculator, will give you eventually 0.181. Okay, you can do your calculation more precisely. Let's check it once more. Let me check my calculation also. Okay, when I recalculated it, my answer is coming to be 0.1799. Also in your marking scheme, the valid range is given to be 0.1795 and less than or equals to 0.180. I haven't done it like the whole calculation at once. When you will do the whole calculation at once, you will get the exact value. Maybe you will get 0.180, but I took it up to 4 decimal places and then added them up and then subtracted from 1, so I get it to be 0.1799, and that is also perfectly correct. Okay, all right, there is nothing wrong in that. So you can also do it directly in the calculator with all the values, put it up together to get the most accurate value. Now part C says the 3 residents of Mahajing are selected at random. Find the probability that one resident classified the bus service as good, one as satisfactory, and one as poor. So 3 are chosen at random. Okay, one said it is good. So what was the probability of getting a good one? It was 0.25. The one is satisfactory, so 0.6, and the one said it as poor, so 0.15. Okay, so these are the probabilities for each multiplied by, as we have like 3 people and 3 factorial will be the possible ways of arranging them, so we'll multiply it with the 3 factorial. Okay, so this is your required probability. Okay, so when you'll multiply it all together, you will get your answer to be 0.135. Okay, that's all about question number 6.